This lesson here deals with factoring, okay? When we're given a polynomial, we need to learn how to factor. And this is going to be crucial as we move forward with our lessons. Okay, we're going to skip this. We're going to go right to this. For this example here, we're going to talk about the greatest common factor. What we're trying to recognize is when we look at the coefficients and when we look at your variables, we need to see what we can take out from each of these. So notice how 12, 8, and 6, right? If I break down 12, 8, and 6 to prime numbers, right? 2, 2, 3 for this, 2, 2, 2, 2, and 3. They've got a 2 in common, and that's it. Just 1, 2. So the coefficient, okay, the coefficient prime factor will be 2. And then when we talk about the x's, 5, 4, and 3, we always take the smallest exponent because that's the most that we'll have in common for all of these. So we put these together, boop, there you go, 2x cubed, okay? Here we go, let's look at this example. Find the GCF of the terms of each polynomial. They don't have an x in common, so let's figure out 15. 15 becomes 5 and 3. 18, I can break down to 6 and 3, and then 2 and 3. So that means they've got 1, 3 in common. Boom, the answer is going to be 3. That's it, okay? How about this one here? 18, okay, well, let's talk about the numbers first, okay? For 18, whoop, that's no bueno. There we go. Okay, 18, okay? 2 and 9, and then 3 and 3. Let's talk about 6. 6, 2 and 3, and then 24. I'll put this over here, okay? 2 and 12, 2 and 3. Wow, 2 and 6, 2 and 3. Okay, they for sure have a 2 in common. Okay, 1, 2 in common, 1, 3 in common. You multiply those together, this will be 6. Now let's look at the y's, 4, 3, and 2. The smallest exponent's 2, boop, y squared. So your GCF is going to be 6y squared. Okay, here we go. Moving on. So now what we're doing here is we're going to factor out the GCF. We're trying to figure out what we can divide the biggest number by. Notice how we went from here to here because we're trying to take out the biggest number and the most variables possible, okay? So here we go. Let me show you this example here, and it's not that bad. Factor out the greatest common factor. Let's do the x's first, okay? Let's do the x's first. Okay, if we do the x's first, oh, and my eraser does not want to work. How about that? Okay, let's reset this here. Whoop, drop that. There we go. Let's screw that back in to get my pen working. There we go. Okay, so what we're doing here is we're dividing to see what we can take out. Notice that we got for the x's 3, 2, and 1. I'm only going to take out 1x. That's it. Because this has 1, 5, and 22. So I'm going to take out an x. I'm left with now x squared plus 5x minus 22. Voila, we got it, okay? So now let's look at the next one here. I'm gonna rewrite this, okay, on a separate sheet. Let's actually do it, yeah, let's do it on here for the sake of argument. Okay, so here we go. Negative 16y to the 6th, okay, so negative 16y to the 6th. And then plus 28y to the 4th minus 20y to the 3rd. So plus 28y to the 4th minus 20y to the 3rd. Okay, so now let's see the biggest number that we can divide by. Okay, 16, 28, and 20. Okay, the biggest number I can divide by is going to be what looks to be 4. Okay, because I can divide 28 by 4, that gives you 7, and 7's a prime number. Now let's look at the coefficients, or not the coefficients, but the degrees. It'll be y to the 3rd, y to the 3rd, y to the 3rd. So we took out 4y to the 3rd. What's left inside? Negative 4y to the 3rd, okay, plus 7y to the 1st, and then minus 5. Voila, there we go. We factored as much as we possibly could, okay? That covers that there. Okay, here we go. Alani is in charge of marketing for a travel company. She is designing a brochure that will have 6 photos. The photos can be arranged on the page a number of ways. There are 2 main squares, which have a side length of x inches on each side, and there's 4 narrow ones, 1 by x inch, okay? So what is the total area of the photos? Okay, so in this case, 2 main squares, okay? 2 times x squared, because the area is gonna be x squared. And then for the 4, it's 4 times 1x. Boom, there you go. Multiply it, that's what we get. Okay, so here we go. Or for the next one, find a rectangular arrangement this time around. So notice how these dimensions are x and x and x and 1, 1, 1, 1, x and 1, 1, 1, 1, x and x, okay? So the arrangement here, right there, 2x plus 4, and this right here would just be x. If I were to factor out the greatest common polynomial, I can take out just an x from this, okay? And there we go, and we got it. So notice how we got that. Distribute after we multiply, bing, bang, boom, we got it. Okay, notice this one here, x, 1, 1, x, x, 1, 1, x, x, x. So this is gonna be 2x plus 2x, oh, sorry, plus x plus 2 actually. So it's 2x times x plus 2. Voila, because we're adding the dimensions together. Not that bad, okay? Here we go. Let's look at this one here. Suppose the dimensions of the narrow borders are increased to 2 inches by x inches. Okay. So now let's for the narrower ones. Okay. So instead of it being 1, it's going to be 2. So in this case, these are x, that's x, but then we have 2 and 2, x, 2 and 2, and then x. So in this case, it's going to be x multiplied by x plus 4 instead. Okay. X times x plus 4, because we're putting those two dimensions by multiplications together, okay? That'll cover that lesson here, okay? Remember, GCF, you're factoring, and you're gonna need this for the next lesson. You'll see. All right, enjoy. This covers 7-4.